Hello and welcome to the AI Game Dev Labs. My name is Champandard, and today we're going to talk about planning in games, and in particular, the lessons we've learned applying planning into games over the past few years, and the opportunities that lie ahead in using more advanced AI techniques, and then some of the games that we've actually applied planning to. So if you're anything like me, you're super excited about the idea of applying modern AI techniques into games, and planning is the one that's particularly interesting. And we've been doing this for about 8 to 10 years now, so we've got quite a lot of experience from applying planning in games. And I'm going to talk about some of those games. So here's a non-exhaustive list of games that use planning or techniques related to planning, and I'm going to dig into them. So I've been lucky enough to work on a couple of games that use planning, and I've also interviewed developers that built planning into many other games. So I thought it would be interesting to dig into some of the insights that they've shared and some of the lessons that we've learned as the games industry when it comes to applying planning into those types of situations. So first let's look at games that use planners. And they can be split roughly into two categories: strip style planning and HTN style planning. And strips, you can think of it as a very non-hierarchical searching through actions that generate new states, and then figuring out how to get from one state to another via a set of actions. HTN is more hierarchical, and it tries to search through actions that break down recursively using task decomposition. And so with strips-based approach, you need to have a good idea of the problem and to have an efficient implementation as well, because it requires a star to search through all the different options. And the first game to really nail that down was Fear, and that's based on the work of Jeff Orkin at Monolith, who applied strips-based planner into Fear. And he did a lot of work to make this run fast enough, and combined with the particular type of game that this was, with action-oriented game where you only really needed short action sequences for the characters in the game, this turned out to be feasible in 2005, and this particular game spawned a whole bunch of sequels and expansion packs, and derivatives of this kind of technology were used in all of those games. And you can actually find the original implementation in the SDK for the original Fear, so you can download that and find the planner. It's actually there, and you can read the whole code for it, so I highly encourage you to do that. You may need a copy of the original game, but it's worth it. So that particular implementation was well documented by Jeff Orkin, and it spawned a bunch of other games that were inspired by it, and two of those were internal to Monolith, like Condemned and Condemned 2, which I also believe used similar or the same code base, strips based also. Then there's a couple other titles, including the Stalker games, that were also using planning. And Stalker uses hierarchies of strips planners to drive character behavior. So whereas the behavior is potentially more complex of the agents in Stalker, or the stalkers as they're called, they break down this complex long-term behavior into a hierarchy of strips-style planners. Just Cause is also a similar kind of open-world environment that also uses a strip-style planner, and the civilians as well as the enemies use that planner for dealing with unexpected situations and the emergent behaviors that you get out of the planner. While planning also helped deal with those particular types of situations. So those games shipped in 2007, 2008, 2010. War for Fall of Cybertron, the Transformers game, also used strips-style planner, which required lots of specific optimizations and graph-based optimizations of strips planners. And Deus Ex, the most recent edition of that franchise, in 2011, apparently used a planner as well. So this is a list of games, a non-exhaustive list of games that uses strips. And there are some other games that use strips, but these are the primary ones. I tried to capture all the key franchises, the AAA games that use planners. There are a few independent games that also use planners and strips style as well. But the other major category is a hierarchical task network. I'm going to talk about those now. And those are inspired by, in particular, the work of Guerrilla Games on Killzone 2, and I was lucky enough to work on the multiplayer bots for Killzone 2. And initially, when Guerrilla did research into hierarchical task networks, they studied strips that was available based on the insights from Jeff Horkin, and they thought that they needed a bit more designer control over the behaviors. So they built a more hierarchical planner, which helps the designers essentially craft a specific tree of behaviors that can be also searched by a planner. And so it seemed to them to combine the best benefits of designer control with planning, and it turned out to be extremely successful. And the bots in the game are, when it was reviewed by the journalists that reviewed Killzone initially, they often were surprised that the bots were actually bots and that they were not online, so they were often fooled by the AI in the game. So obviously Killzone's AI was extended and reused in Killzone 3, and Transformers, the War for Cybertron, borrowed that approach as well, and also implemented a hierarchical task network style of AI. So initially, all these implementations were derived from SHOP. That stands for Simple Hierarchical Ordered Planner, and it has lots of advantages. It's a simple algorithm, but that's on purpose, and the advantages that it has are effectively because of design, and it allows designers to express nice hierarchies, ordered hierarchies of plans that you can understand exactly how those will get chosen in the game. So you have full control over a specific type of behavior, which makes them particularly well suited for creating character AI. So Killzone 2 uses a subset of SHOP. It does not track exactly the side effects of each action as they're applied to the current world state as it searches forwards through the set of action, or as it searches forwards in time, whereas Transformers does that, so it tracks the side effects of each action. Killzone 2, on the other hand, uses the propositional logic of SHOP, but Transformers doesn't. So we found different games that use different subsets of the SHOP algorithm, and those have proven to be useful in different practices, but we haven't fully seen a full implementation of SHOP applied to games yet. But we found hierarchical planners to be extremely useful, generally speaking. So those are the games that use HTNs officially and are well documented, and there are a couple other games that use hierarchical task networks unofficially, which I've discovered based on my personal research and gossip. So I'm guessing partly here. I believe Max Payne 3 uses a hierarchical task network planner based on the work of Peter Gorniak, as well as Demon's Souls and Dark Souls as well. Max Payne, I think, uses some HTN concepts within its squads. So that was a presentation at GDC 2009, but it's not official. And when the Total War series, when Empire came out, there were some rumors that it also used a planner, and we invited Creative Assembly to the Game AI conference to give a presentation about the AI, and it turns out it's more of a hierarchical approach and not a strip-style implementation. And it also turns out it's a little bit more reactive. It doesn't fully search everything ahead like a fully featured HTM planner. But this is important to emphasize. It draws the line between planners and the more reactive techniques that are used in industry, like behavior trees. And it's hard to often find the gap between the two, or where do you draw the line between a planner and not a planner. And there are certain things that are called reactive planners in academia, and the game developers have embraced this type of technique, and these techniques use search, but not searching ahead, and I'm going to talk about those now. So a behavior tree, for instance, will look exactly like an HTN, except it does not search ahead in time. It stops at the current action and says, this is likely to work out, I'm going to try it out. So behavior trees have been extremely popular in games, and in particular since Halo 2. There was a presentation that Damien Isla gave at GDC about the behavior trees in Halo 2, and there are a couple of other titles at the time that also gravitated around similar ideas, and SWAT 4 was one of them, and Facade was another. And this is inspired from a lot of work done in robotics or the virtual agents community. And things have kind of crystallized since then, and there have literally been hundreds of titles based on behavior trees and many different games. But I'm going to talk about specifically some titles that have relations to planning, or that somehow bridge the gap between the two. And Metro 2033 was a stealth action game that the developers had some experiences of applying planning from the Stalker games, and they initially used a planner, but then they switched to using more behavior tree style AI, not very hierarchical, quite flat tree, and that turned out to be better for them to get more control over the behaviors. And the game has a lot of similar functionality than the Fear franchise, for instance, and it plays a lot in the same way. So it shows that similar behaviors can be implemented with different techniques, and that some of the strips, the original strips planning techniques, did not necessarily create different behavior. They just allowed the developers to create that behavior in a different way. Another studio that's worth mentioning is Avalanche Studios, who built the strips planner in Just Cause 2. Now, at the latest Game AI conference, we had a panel discussion about this, and Avalanche has actually got its own internal behavior tree implementation now as well. So it had a planner available, but it decided to use behavior trees for certain projects, despite having the planning technology available, for many reasons that we've talked about, including designer control. And it seems, well, it may seem obvious, but it's become obvious to the game developer industry now that certain techniques are better suited to different types of games, and in the more action combat oriented games you can get away with such reactive techniques like behavior trees. So we've talked about a lot of stealth based games and a lot of more interesting open world games like Just Cause 2, and planners are more justifiable in the large complex open world type games than in the more linear scripted type games. Obviously you need less of a planner in such a closed off environment where there are fewer choices available to the AI. So behavior trees remain a very popular option in industry. Another set of techniques that are used in games are utility systems, and utility systems tend to be used in very specific systems of games, like weapon selection, or it's selecting enemies, or in action combat games they're used for these particular decisions. And you can think of a utility system as a kind of like a spreadsheet. So of all these different options that I have, which one should I pick, which target should I pick, which weapon should I pick, which smart object should I interact with. And what's interesting about utility systems is that there is a gap between, or there's a bridge between them and planning systems. And Demigod is one of those titles that bridges the gap between a utility system and planners. So Demigod is a multiplayer online battle arena, a MOBA for short, and it has many challenges for the AI in particular. And it uses planning style algorithms as well, combined with utility. So instead of searching for a specific goal based on Boolean criteria, where each action has strict dependencies that need to be satisfied, Demigod uses search, like a depth 2, depth 3 of a set of actions, and it tries to calculate a score for what it's done. And so it then figures out if a specific combination of actions have a higher score or lower score, not necessarily looking to satisfy a Boolean goal, but using search to maximize a specific utility. So the application here is significantly different, but it's still using search to automatically find sequences of actions that are sensible for the AI. So that's why it's got many aspects of planning, but it's also got many aspects of utility as well. And I think that's a very promising area that is very underexplored, and certainly very suited to these multiplayer online battle arenas. And I presume we'll be seeing more of those types of AIs being built as MOBA games become more popular. Another style or another type of game that I'd like to talk about is the multiplayer bots implemented in, for example, Section 8 prejudice or Section 8. Now, this is worth mentioning because TimeGate had experience working on the expansion packs for the original Fear, and they built the AI, or they worked with the planner and the AI in the planner, the strip style. But for their own game, for Section 8 Prejudice, they chose to build a utility system for the bots instead. So this is another action combat game where the bots have to make fast decisions, and they found that utility worked perfectly well for this particular purpose, and they did not need to implement a planning system, despite having the experience with that. And this emphasizes again that fast-paced action games are not necessarily the best types of game to implement planning in, although planning does have its advantages as well, which we'll talk about shortly. And the third game that I'd like to talk about that's utility-based is The Sims, and The Sims 3 in particular. Now, earlier in the franchise, The Sims 1, The Sims 2 were almost entirely based on utility. But The Sims 3 took that a bit further, and the characters were more purposeful. They could all interact with each other within a neighborhood, and there was not just a single household that was simulated at the time. And to make this work, to pull this off with sufficient performance, Richard Evans had to build conceptually a hierarchical planner into the system to partly isolate the utility system into sub-decisions, so that the whole thing was not utility-based, but it was more like driven by the planner and then using utility at the base. So in a sense, utility was relegated or isolated a little more, and more responsibility was proportionally given to the hierarchical planner to really pull this off. And The Sims 3 is an interesting case study, and looking forward, I hope to see more games with purposeful characters like those in The Sims 3. And it certainly shows that there's a lot of potential in combining hierarchical planners with other techniques like utility to get really great behaviors. So what have we learned from all this? And we've basically been applying planners in games since Fear. That's the first documented use of planning in games, and it's been almost 8 years since then. So in that time, we've learned quite a lot about planning in video games. Certainly not as much as in robotics. They've been doing it for decades, but we still have a lot of insights. So one thing we found that, as far as games are concerned, technology is really rarely the problem. And now, initially, to get the strip style planner into Fear, Jeff Orkin had to do a lot of work to get that running fast enough. And he has a paper on the subject entitled "How to Plan in Real Time and Keep Your Job." So it certainly was a performance problem initially, but a lot of developers have benefited from his insights since then, and that kind of optimization work is becoming less important now, as we have more processing power to be able to throw at the problem. And so it's fair to say that these technical issues are secondary now to design issues, and that's my second point here. That a lot of the questions that game developers are raising about planning is how to combine automated planning with designer control, and that's a big open question about game AI in general. How do you combine those two things? And it turns out that hierarchical planning is currently our most promising direction that we're heading down. Hierarchy allows you to edit specifically what types of decisions you'd like to constrain, and if you want a very constrained decision, you'll build a very narrow tree that goes more deeply. But if you want to give the planning more options, then you will build a tree that is much more broad and that leverages the search more as opposed to the designer's structuring of the tree. So these are big open questions. How do we balance those two things? But we've learned that hierarchies are a very good way of doing that, and that's why simple algorithms that look simple from a research point of view, like SHOP, are very interesting from a game developer's point of view, because they're simple and they provide that simple specification as a kind of language for the designers to use and to craft behaviors that they can control. The third big lesson that we've learned is that when we're less sure about the domain of how to build great AI, then planning has many benefits. And Jeff Orkin mentioned that benefits of using planning on fear was also during development they could throw together prototype behaviors and quickly get results without necessarily understanding the impact of the features that they were building. They could get great looking behaviors quickly. And if you have large unpredictable open worlds, maybe Stalker or Just Cause, planning could also help if you don't fully understand where things may end up or how objects may interact. Planning is potentially a good way to get around these problems and still provide robust AI. But conversely, in domains where we have a very clear understanding of what the problem is and what the scope of the level is, or which objects may interact with others, like tightly scripted action games, developers building such types of games have found themselves moving away from planning techniques because, well, they can do the same thing without searching ahead and using more reactive techniques instead. A third important point, and probably one of the biggest lessons that we've learned here, is that goal-based architectures are very exciting from an architectural point of view, regardless of whether we use planners or not. So a goal-based architecture is conceptually separating what to do and how to do it. So if you separate those two things, it doesn't matter how you implement it. You can implement that using a planner, behavior tree, utility system, and you still have a lot of benefits in your architecture, and it turns out to be a very healthy architectural separation. So you can have the designers work on specifying what they want and have an algorithm implement that in a different way. Search is just one way to implement that, or planning is just one way to implement that as well. Another thing we found is that planning hasn't yet really made or broken any particular game, and I'd like to see that. I'd like to see a game where a planner is absolutely necessary, but currently we've found that planners are just another technique that can implement AI decision making for characters, and that most games could use behavior trees, utility systems relatively interchangeably, and you wouldn't really notice much difference. But what I would like to see is a game where planning is actually absolutely required, and you could not build that using a reactive technique. And there's been very little investigation of that, and that kind of ties into my big opportunities for planning and for these techniques in general. So in the long term, I think the big potential of planning is that we will have more intelligent characters. Planning is super talented and super good at deliberation and logical reasoning and figuring out how to achieve a goal based on actions that are combined together. And intelligence isn't the only thing we're looking for in games. We want the characters to be believable and entertaining, but intelligence helps a lot, and it will help us make more believable characters, certainly. Second big long-term promise that planners can help us fulfill is the idea of a game master or a game director that can custom craft or tailor an experience for us. So if a designer has a plan for us and he cannot supervise every single game instance in the world, then potentially he could build a planner into that game and have the planner help change, update the story, give new quests based on what's going on, and really join in the storytelling to make each game experience fully unique. And this is something that we're barely scratching the surface of, and there's a lot of potential here. So in the short term, there's three big things that I think are promising avenues for planning. The first is applying planning to other domains and not just characters, and specifically not just enemies. So we've done action combat games, and we've done them too well. Now let's try some different types of games, and The Sims 3 is pointing in exciting new directions of how to potentially use planning techniques in different kinds of environments, but we haven't really scratched the surface of this either. Again, so not just exploring different types of game applications, but also different types of games. So RPGs or simulation games could also benefit from planning. And also, I think in the short term we have a lot of potential in applying planning techniques during the development as a tool. So if you think of Planner as a way to compile and create more reactive AI that will run very efficiently, but we can do all the computationally expensive calculations. Once the designers have finished tweaking, tuning all their settings, we should in theory know the domain fully that we can bake that and send that to the customer as a reactive AI that has everything it needs to be able to make decisions effectively without having to do runtime search. Not all games will work with this, but I think there's a lot of potential in doing that for many types of games, and surprisingly many. So if you'd like to find out more about this, I've compiled a list of interviews that we've done. So on all the games that I mentioned today, all of those interviews are available online, so I encourage you to go and watch them if you would like to get more information about that. So I've compiled all those things together. Go to aigamedev.com/planning, and you'll be able to see that list of interviews. And if there are any further references, I will update this page and put them there as well. If you have any comments, of course, you can write to us on Twitter @AIGameDev. So that was an overview of planning in games, and I hope you're as excited about planning as I am. I think we've barely just scratched the surface, so I look forward to the next 10 years of planning in games, more so than almost any other technique, and it'll be exciting to see what people come up with. So I hope you share that enthusiasm, and until then, I will see you online at AI Game Dev. Take care, bye.